Hello my dear students, I am B S Pandey, your physics lecturer. Students, in standard 12th lectures, we are here. We have entered in chapter number 7 of NCERT, it is alternating current. We have done till now in alternating current how AC produce, and we have correlated alternating current with the voltage. Okay students, so today we will start the root mean square AC, that is the RMS AC and voltage. But before that, my dear students, I'm going to give you a question you have to solve, because that will help you to reach to the RMS value of AC and AC current and voltage. Okay, so today we will be in lecture number 73, my dear students. Lecture number 73 of NCERT chapter 7, it is alternating current AC. Alright, yes, we have studied the alternating instantaneous value of voltage ET as E naught sine omega t, where this omega is 2 pi over t, or you can write 2 pi f. Here f is the frequency. In India its value is 50 Hertz. We have studied. Then after, if we are having the resistance, then we can get the current through that circuit. It is as I naught sine omega t. Again the omega, it is same as above. My dear students, here E naught and I naught we have studied. E naught and I naught are the peak values. Okay, today we will correlate, we will study the relation between this peak value, and the new thing we will study it is the RMS value. All right, now before going to the next topic, it is the RMS value, my dear students, I am going to give you a question. Could you find the integration of this one? Suppose any quantity, it is x, you have to find. Here I naught sine omega t square dt. If I'll give you the I naught sine omega t to integrate with dt with particular value, suppose it is for full cycle, then you will integrate very easily. My dear students, here the square function you have to integrate. How you will solve this question? Okay, look at carefully, my dear students, because for calculation of RMS value, for calculation of power, average power, instantaneous power, we will use the same concept. Okay, now I'm going to solve this question. I know that the number of students you can solve this question. This is not very difficult integration. You have studied in the standard 11th as well. So let me solve this one. Here we can write I naught square sine square omega t and dt from 0 to full cycle t. My dear student, you can see here the I naught is constant, taken out. Here the sine square omega t and dt for full cycle. Here I naught square, we know that in the sine square function we cannot integrate, so we are going to convert. We know that the sine square theta, it is a 1 minus cos 2 theta divided by 2. So it is 1 minus cos 2 omega t over 2 and dt. Alright, yes, for full cycle 0 to t. Now you can see here I naught square, it is constant, taken out. My dear students, we will integrate. The 2 will be out, so it is integration of dt, 1 multiplied with dt for full cycle minus the sine and cos 2 omega t dt for full cycle. Here I naught square by 2. I hope you understand now how to solve this. So it is dt will be t minus 0, it is t itself, minus cos 2 omega t dt. The integration of cos, it is we know that the differentiation of cos becomes sine, but the integration of cos becomes minus sine. So it is the minus sine 2 omega t divided by the constant value, it is twice omega from 0 to t. Okay, here I naught square over 2, the values you are putting here, sine omega t, you have to put the t as t sine 2 omega, it is 2 pi over t times t divided by 2 omega minus 0. Could we write? Yes, we can write. When we'll put the value 0 here, behalf of t, then we'll get sine 0. Altogether it will be 0. My dear student, you can see it is the I naught square by 2 here, I naught square by 2 t plus here the t will be cancelled out, so you will have here the 4t and sine n pi, we know that, 4 pi and sine n pi, we know that 0. So this will be the entire value 0, and we are having here the I naught square t over 2. Alright, so this is the answer of this value x. In this way, I hope students you got it. Kindly pause the video and try to understand. Whenever you find the difficulty, let me know by any means or method. Hope you understand. Now, my dear students, one more question I'm going to ask you, but this is not very difficult question. You have to think using your IQ. My dear students, we have drawn the graph of AC and DC in last lecture. You must remember. I know that you have remembered that one. Here, my question, my dear students. Suppose I'm having 2 containers. Alright, here look at carefully. This is the container 1 in which water is kept. Suppose 1 liter water is kept. Okay, 1 liter water it is kept. Another container I'm having in which another 1 liter water is kept. Here I've given this container, the coil is connected, another coil is connected. Here we have given the 10 ampere DC supply. Okay, 10 ampere, and here 10 ampere AC supply we have given. Now my question, which current will heat the water up to certain temperature? Suppose the temperature of this water become 50 degrees Celsius. 50 degree Celsius, and this could be also the 50 degree Celsius. Alright, which will take the time longer, T1 and T2. In which case the time will be longer to boil the water up to, to heat the water up to 50 degree Celsius by this AC supply or by this DC supply. This is my question. Now, if you got the answer, try to analyze, and if you got the answer, tell me. Now, look at here, my dear students. When we supply the DC, the 10 ampere, this is the amplitude of DC current, and this is the AC current. But remember, the 10 ampere I have given for the AC current, what does it mean, and what does it mean by the 10 ampere of DC current? Let me draw the graph. Here, if I have given the 10 ampere of DC current, of course, if this is the DC, remember, I have not given the condition whether this one is the fluctuating DC voltage, but if this is the DC current, alright, the constant DC current, it means for each second, if this is the time and this is the amplitude of DC current, I, so for each second you can find out here the 0 second at the 10 ampere, the current pass through it, and for each second you can see it is the 10 ampere going. Alright, for each second. But here, in case of AC, if this is the graph of AC, you can see if this is the 10 ampere, the maximum peak value, it is the 10 ampere, the current, and this is the time, then you can see this 10 ampere reach to the circuit or supplied to the output for not for each time interval. Here you can find out the 10 ampere, here you can find out the 10 ampere, but before that value and after that value you can see it is less than 10 ampere, it is less than 10 ampere, even sometime it will supply 0 ampere. You can see over here also 0 ampere, you can see over here the 0 ampere. It means for the same time, if it is time t, the one cycle, if you go to the time t for the one cycle, whatever may be the time, you will find for each second this one is supplying the 10 ampere and this one is not supplying the 10 ampere. This is the maximum value, the 10 ampere. It means it will supply below 10 ampere also, but it cannot supply more than 10 ampere. Alright. And I ask for the same heat. Remember, the heat supply, it is H1 and S2 should be same. H1 can be written as the I square for DC, I square R, and in time t, if it is t and the resistance of each coil, suppose it is the same, okay, there is no differences between the resistance. Here the H2, it is the I AC square R time t. But this two value will be same. It means to increase the time, to equalize, you can see here the current is less than the DC, because DC continuously supplying the 10 ampere, but it is not supplying the 10 ampere. It means this H2 will be of 10, which is equals to the H1, not exactly at the time t. If it is time t1 and if it is time t2, then you can say this t2 should be greater than t1. It means first this DC will heat the water, up to 50 degrees Celsius. It will take longer time to heat the water up to the same temperature. It means this AC having the more power than the DC. Remember, this is the misconception. If you are the student of science, then you should realize, yes, this DC has the more power. It can boil the water quickly and in very short interval time compared to the AC current, and this is the reason. Okay, I hope you understand this concept, my dear students. Now, do you know if this is the AC current, it is 10 ampere maximum. You can see here the number of values you are getting, but whenever you will see to the stabilizer in your home, your household circuit, you will find that there is a constant value reading over that stabilizer, 220 volt or the 225 volt and whatever. So could you tell me what is that value? The 220 or the 225 volt, if you get from there. Actually, you can see it is the 10 ampere or whatever maybe the voltage, we will correlate the voltage you read over the meter. It is not the peak value. Remember, if in question it is given the 220 volt, that is not the peak value. Remember, that is not the peak value. Then what is that value? It is mentioned in the book or you read over the stabilizer. Actually, that is called the RMS value, root mean square value. It's around the average value, not exactly the average value. We will try to obtain the average value also, but it is around the average value, and that is called the root mean square value that you read over the meter, and it is mentioned in the books. That is the RMS value, and we are going to study right now that particular value of AC current and voltage. So give the heading, my dear students, RMS value of AC. RMS, that is the root mean square value of AC. It is RMS value of AC. This could be the AC current or AC voltage. Alright. Now, again, to understand this RMS value, I am going to give you an activity. The same activity, my dear students, you will find here the two beaker I am having of the same volume, and these two beaker are filled with the water. Suppose with 1 liter, it is filled with water 1 liter and supplied by the current. Here, my dear students, I am supplying the alternating voltage and direct voltage. This is a coil and this is another coil, the heating coil. Both the coil having the same resistance R. Okay, and through both the coil we supply the current for the same time. Here, let me write for the time interval T. Listen carefully. The same resistance and we apply the current for the same time. But what is the differences? Here I am applying the DC current and here I am applying AC current. Okay, DC current and AC current. Here, if it is I DC and it is I AC, we could write both the water, it is reached to a certain temperature, suppose, and it releases the heat H joule. This is also releasing the heat H joule. Now, could you tell me, my dear students, which value of current I DC or I AC should be higher to supply the same heat in same time with the same resistor? Of course, you can give the answer. Right now we have studied. Here, we know that the voltage, that is the current, through AC should be larger. If we want to get the same heat in same time through the same resistor, then we should maintain this AC current little bit higher than the DC current, because this DC supply the constant value, so it should be higher. Now try to understand the RMS value. The RMS value of current is that value of DC, which produces same amount of heat, If it applies, it produces DC through the same coil in the same time of same resistor, which is produced by the AC through the same resistor in same time. Okay, if it is H AC, so if these two are equal, DC equals to H AC, then the current which produces the same heat as AC done is known as the RMS value of current. I hope you got the definition of IRMS, that is the RMS value of current and voltage. RMS value of current is that amount of DC current which produces same amount of heat through the same coil in same time as done by AC. Okay, this is the definition. You can replace that current by the voltage, you will get the definition of RMS voltage. That was the definition of RMS current. Okay, I hope you are much clear about it. Now our aim is to obtain the equation. Okay, so we are going to find here the equation. Look at here. H DC, it can be written as the I square R dt. Alright, we will integrate to get the value. Remember, this current will be the RMS. If it is equal to the I naught sine omega t. Alright, this is the AC current, I naught sine omega t. We have studied R dt. In what time? In the same time, 0 to t. Okay, in same time. Now, my dear students, we are going to find out here the relation between these two, RMS and peak value. Look at here, my dear students, this RMS, which is the constant value, R it is constant, dt it will be the I, R ms square and rt, which is equals I naught square. We will take out, I think the r and r should be also out. Now it is sine square omega t dt from 0 to t. Now could you find the value, my dear students? Could you integrate this one? You have been taught how to find the integration of this value, but again I'm going to find the integration of this particular value, although I have given you the concept. If you can solve, then pause the video and try to solve, my dear student. Here I naught square r 1 minus cos 2 omega t over 2 times dt from 0 to t for the full cycle. Okay, now from here I'm going to find here the value of integration. It is equals I naught square r divided by 2. It is dt minus cos 2 omega t dt from 0 to t from 0 to t. This value will be 0, you know, we have integrated right now, and this will be the I naught square r t over 2. It is t minus 0, it will be t, and this is equals to how much? It is I RMS square rt. So I RMS square rt, it is equal to this one I naught square rt over 2. The rt will be cancelled out, so I RMS square, it is equals to I naught square by 2. So the I RMS will be I RMS, it will be I naught by root under 2. This is the I RMS value of current. Now my dear students, if R is the resistance of that coil, we have studied already. If R is the resistance, then we can write what we can write here, the ERMS IRMS into R, that is the resistance. So ERMS can be written as, you can see, it is IRMS I naught by root 2 times R, and I naught is nothing but the E naught by R times R by root 2. So it is ERMS is E naught by root 2. So we can write here ERMS and IRMS we got. It is ERMS, it is E naught by root 2, and IRMS, it is I naught by root 2. Now my dear students, you can see here the peak value and RMS value, we got the relation between peak value and IRMS value. You can say the peak value, it is root 2 times greater, it is root 2 times higher than the RMS value. That is the root 2 times RMS value is the peak value of AC, that is AC current or voltage. Okay my dear students, now you can solve few questions on the basis of this this equation of RMS voltage and RMS current. If you understand this, try to solve a very simple question, my dear student. Here I am going to give you a question, the same type of question you will find it has been asked in previous year, and you will find in NCERT the questions are starting like this way. I am going to give you the same level. Here a bulb rated with an electric bulb. Its power, it is 100 watt. Alright, it is mentioned, and it is made up at 220 volt. This is the rating of the bulb, nothing more you have. Now the question, you have to find the first RMS, the second E0, third resistance of the bulb, fourth RMS of the current. Could you solve this question, my dear students? If you can solve, try to solve this question. Pause the video and try to solve this question. My dear students, we have studied in chapter electric current about this power. What we have studied? The power, it is V square over R. Here it is E square over R. As I told you, if in question it is given 220 volt, remember this is nothing but the RMS value. It is given. What is given? The VRMS or the ERMS, already it is given. ERMS is 220 volt. Am I right? Yes, it is given. So your answer ERMS, you got. The first question has been solved. It was very simple. Actually, it is given. Now the E0, we know that. The second one, we know that ERMS, right now we have studied, it is E0 by root 2. It means E0 will be root 2 times, that is 1.4 times 220 volt. In your household, remember the peak voltage, you didn't get 220 volt. The peak voltage, because that is the AC, alternating current, that's why the peak voltage you get, it is 220 times root 2. Alright. Now the third one, you have to find the resistance. So you can find out the resistance from this formula only. The resistance, it is E square, that is the RMS, square over R. Alright, E square over R, because this power actually measured with the RMS value. Alright, so the R, it is ERMS, sorry, it should be the power P. All the values are given. ERMS already you have been given. ERMS how much? It is 220 volt, and the power it is given 100 watt. Then you can find the resistance. The next one, it is the IRMS, and we know that IRMS is equals to ERMS over resistance. Already you have been calculated here the resistance. You are having the value of ERMS. How much? It is the ERMS you have been calculated over here. It is. So the IRMS will be the ERMS divided by resistance of the bulb. So my dear students, in this way you can solve the numerical problem. Okay. This much very simple topic we have discussed here today. It is the root mean square value of AC current, that is the current and voltage. And in next lecture, my dear students, I will teach you about some circuits containing different devices under given load of AC current, that is the circuit under AC supply. We will supply the AC to the different circuit and will find the various quantity. We'll try to find out the current, we will supply the voltage, AC voltage, and we'll try to find out the AC current. We'll try to find out the power, instantaneous power, and what will be the average power in that circuit. We will also study the phasor diagram, how this phasor diagram helpful to study the various alternating quantities. Okay, my dear students. So this is all about today's lecture, my dear students. Thank you very much.